Today we're going to talk about variables. We'll talk about categorical and numeric variables. We'll talk about discrete and continuous variables. We'll talk about the different way that we measure variables. And lastly, we'll look at how MagicStat handles different types of variables. So first, what is a variable? A variable is, quite simply, anything that can vary. It's able to vary, it's variable. So for example, we might look at different types of smartphones, either Android or iOS. The type of operating system that the phone is using is a variable. Similarly, if I'm at a coffee shop, people are either drinking regular or decaf. The type of coffee that they're drinking is a variable. In contrast, a constant is anything that doesn't vary. It stays the same. So let's look at some examples here. So variables can be either categorical or numeric. Categorical variables differ based on different categories, right? Whereas numeric variables are distinguished based on some sort of a numeric scale. They have some sort of a number that's associated with them, and that's how they distinguish themselves. The variables I already mentioned, like phone operating system and type of coffee, are both categorical variables. An example of a numeric variable might be the score in a basketball game. It could go from 0, like if a rec team is playing against an NBA team, to well over 100 or even 200 if it's the NBA team against that rec league. An example of a constant might be the number of teams in a basketball game. There will always be 2 teams in a basketball game. There can never be more or less. Another constant might be that there are 7 days in every single week. So when we think about categorical variables, we think about describing them using words. And similarly, a numeric variable is described using numbers. Now, just because it's a number doesn't mean that it's numeric. For example, the Japanese puzzle game Sudoku uses numbers, but they could just as easily be any group of 9 unique symbols. Another example might be uniforms for soccer players. Player number 10 isn't more than player number 4. The numbers are just there to distinguish one player from another one. They could be names or shapes or anything else that would uniquely identify the players. Okay, that's categorical and numeric variables. Within numeric variables, there are discrete and continuous variables. In a discrete variable, there's no value in between. There's no value in between any 2 other values. So again, basketball score would be an example of a discrete variable. You can't have, 20 and a half points, right? In contrast then, a continuous variable, there is an infinite number of values between any 2 other values. Examples of continuous variables might be time. There are an infinite number of values in between each second. There are hundredths of a second, thousandths of a second, millionths of a second, and so on. It just depends on the quality of your timepiece, right? Temperature is another example of a continuous scale, and also weight would be an example of a continuous variable. So speaking of scales here, let's look at the scales that we use to measure variables. We have a nominal scale, we have ordinal scales, interval scales, and ratio scales. So let's think about what we're thinking about for each of these. We have for nominal, that just means names, right? That's the nominal is Latin for name. For ordinal scales, we're looking at rank order. For interval scales, the key here is equal intervals. And for a ratio scale, there is a 0 that is meaningful. So let's look at these a little bit deeper. So for a nominal scale, there's no order to the scale, right? So eye color, one eye color isn't better than another eye color. Political party, one's not necessarily better than another. For different flavors of macarons, no one flavor is better than another. They're just different, okay? Now, starting with ordinal scales, there is an order to them. So freshman, sophomore, junior, senior in school is ordered in terms of the number of years that you've been at the school. For first, second, or third place in a sporting event, these are ordered. Or the classic Likert scale is an ordinal scale. Okay? Now the difference between ordinal scales and interval scales, for an ordinal scale, the ordinal is all that matters. The distance between the 2 points is meaningless. There's no the difference between first place and second place isn't necessarily the same as the difference between second place and third place, right? All that matters is that they are in some sort of order, right? For interval scales, the distance between each point is equal. So the classic example for an interval scale would be temperature. A 1 degree difference between 0 and 1 degrees is the same as the difference between 100 degrees and 101 degrees, or 55 degrees and 56 degrees. For interval and ratio scales, in an interval scale, 0 is just another number on the scale. It doesn't have any sort of special significance. Whereas for a ratio scale, a 0 means that there is nothing in that, it represents an absence of that variable. So classic example of that would be, again, weight. 0 means that there is no weight. Whereas, for example, a 0 on a Fahrenheit scale doesn't mean an absence of temperature. That would be Kelvin scale would be 0 would be an absence of temperature. So a Kelvin scale would be a ratio scale, whereas Fahrenheit and Celsius are both interval. So looking at some examples of different scales, I'll put these on the screen and I'll give you a second and and then we'll go back and we'll talk about which one each of these is. Okay, academic major is a nominal scale because one major isn't better than another. IQ score, this one's a little tricky. It's an interval scale. The difference in one IQ point is the same whether it's from 81 to 82 or from 127 to 128, but somebody who's got an IQ of 140 isn't twice as smart as somebody who's got an IQ of 70. A size of t-shirt is an ordinal scale. Medium is bigger than small and large is bigger than medium, but the differences between those two sizes isn't necessarily equivalent. Words typed per minute is a ratio scale. Here, 0 is meaningful, and somebody who types 100 words a minute is twice as fast as somebody who types 50 words a minute. Favorite color is also a nominal scale, where one color isn't better than another. And liters of sweat produced during a stats exam, like words per minute, this is also a ratio scale. Okay, so let's take a look at how variables are handled in MagicStat. So I will go to magicstat.co and pull up. I'm logged in. First, I'll open the data file. I'll open this data file in Excel real quick so we can see what it looks like. So I have an auto increment ID variable here, a unique identifier for each person. And we have runners here, people that trained either inside or outside. And we had the temperature of their when they trained. We have how long it took them to run the race, and then I have organized these by place, from first to last. Okay, so let's take a look at that inside MagicStat. So when we load it here, we can see our first 5 and last 5. This is exactly what it looks like, what it looked like in Excel. So our ID, a unique identifier here. Then we have our the training location. And again, this is a nominal scale. We're inside or outside. This is just a categorical variable. As we see down here, MagicStat automatically identifies each variable as either categorical or numeric. So we have a nominal scale here. Our temperature is an interval scale because 0 isn't meaningful. It's just another number. Our time is the ratio scale, and place here is our ordinal scale. And so we see again then that MagicStat has classified these as either categorical or numeric. However, we can switch back and forth between these if we need to, if we feel like that there's been a mistake. And in this case, maybe we say that our unique identifier, even though these are numbers, that's just because it's convenient to use numbers here. This could be anything, any sort of unique identifier works. So this is sort of like the number on a soccer jersey or something like that. And so really maybe I can just say that this is categorical. So if I want to do that, I can just go back here and I can click categorical, and then MagicStat will update that. And now ID is here in the categorical variables. Okay, so thanks for watching this overview of the different types of variables. If you'd like to learn more about variables, make sure to check out our video on independent and dependent variables.